Okay, so just like last time, instead of just telling you the rule, I want to come up with the rule so that it means something to you, okay? So we're going to accomplish that the same way we did last time with kind of expanded form. So let's just do a nice, simple example to begin. What does 7 to the 5th look like in expanded form? There you go. 7 times 7 times 7 times 7. All right? 1, 2, 3, 4, 5. And then I bring that back down to a single power. What would that be? 7 to the 5th power, right? Not a trick question there. Just comes back down to 7 to the 5th power, okay? All right, let's try one that looks a little bit different. So you guys told me 7 to the 5th power is 7 times 7 times 7 times 7, 5 times, right? What would x to the 3rd power be? X times x times x, right? X to the 3rd power would be x times x times x. So anything to the 3rd power would be it times it times it. Am I safe to say that? Anything to the 3rd power would be it times it times it. So now I'm not just having a single number or variable that is raised to the 3rd power. You see on that second line there, we have 7 to the 5th that is raised to the 3rd power. So along the same logic, essentially I'm just taking 7 to the 5th and multiplying it out 3 times. So I have 7 to the 5th times 7 to the 5th times 7 to the 5th. Do you want Mr. Craw to be big meanie pants and make you write out 7 5 times, times 7 5 times again, times 7 5 times again? No, you should know this rule now, right? This now just turned into a multiplication, a multiplication problem. I have 7 to the 5th times 7 to the 5th times 7 to the 5th. What do you do with exponents here? What? You just add them together, right? Because I have 5 7s here. 5 more here, that makes 10. 5 more here, that makes 15. So now, bringing it back down to a single power, I have 7 to the 15th power. Okay, I want you guys to do the 3rd line together with your groups. I'll give you 20 seconds. Do the 3rd line together with your groups. Go ahead. Okay, so you should have x squared times x squared times x squared times x squared times x squared. 5 times there. And then bringing it back down into a single power, we have 2, 4, 6, 8, 10 x's. So x to the 10th power. Okay. So let's pause there for a second. Let's go ahead and fill in our rule. Okay, because the last one is kind of driving home a different point. So let's go ahead and fill in our rule. So I'll give you about 10 seconds with your groups. See if you guys can come up with the rule about when you're raising a power to another power. Go ahead. Okay, so we don't want to have to do the expanded form every single time, right? Because that can get cumbersome, especially if we get high exponents. So instead of doing expanded form every time, what rule could we use when raising a power to a power? Multiply the exponents, right? Good, so I'm going to multiply the exponents. Right? Because if I have 7 to the 5th to the 3rd, well, this is how I logically think about it. Remember, I always tell you guys, talk through the problem in your head as you're doing it, right? If you just kind of start writing stuff down and you're not really thinking, you're going to make mistakes. But if you talk yourself through it, this is how I talk myself through 7 to the 5th to the 3rd. So I think, okay, I have 5 7s, and those 5 7s are written out 3 times because it's raised to the 3rd power. So if I have 5 of them written out 3 times, it's logical to me that I would multiply 5 times 3 to get 7 to the 15th. If I have 2 x's, that's x squared, written out 5 times. Well, if I have 2 of them written out 5 times, that's 2 times 5, which is 10. So I get my x to the 10th. Okay? Let me drive home one more point with our top box before we move on to some examples. What is going on? My stylus is not working. There we go. Okay, so let's look at this bottom box for a second. -4 to the 3rd power. So think about it. If I took -4 to the 3rd power, how many negatives do I have in my problem? 3. Would 3 negatives being multiplied together give you a positive or a negative answer? Negative, right? So what about if I took -4 to the 17th power, would you tell me my answer is going to be positive or negative? Negative. How do negatives cancel? A negative times a negative. So they cancel in pairs, right? Pairs imply even numbers. So if I gave you negative 4 to the 20th power, would your answer be positive or negative? Positive, because it's an even number, right? So if I'm ever taking a negative to an even power, I know my final answer should be positive. If I'm ever taking a negative to an odd power, I know that my final answer should be negative. Okay? So that's just a little kind of, not really a trick, but just something to remember when you're doing this that can make your sign a lot easier. Okay? All right, so let's go ahead, and you have 5 examples right underneath that box that I would like you guys to do. I will warn you, be careful on D and E. D and E are mixing the rule you just learned with rules you learned last time. Okay? So A, B, and C are just straight the rules that you learned today. D and E mix the rules that you learned today with the rules you learned last time. Let me just ask you a quick question in preparation. Order of operations tells you to do what first? Parentheses, and then what's next? Exponents, and then what's next? Multiplication. So make sure you do exponents before you do multiplication, meaning you're going to do this power to a power stuff that we did today before you multiply like we did last time, okay? So that is my warning and helpful hint to you on D and E. So go ahead and do those 5 together with your partners. Go ahead. Okay, so on A, I have 3 x's that are then written out 6 times. So 3 times 6 gives me 18 of them. So x to the 18th. B, I have, remember this is a base, not a coefficient, so I have 4 of them written out 7 times. So 4 times 7 leaves me with 28, 2, so 2 to the 28th. C, I follow along the same lines. I have 3 of them written out x times, and I realize that's a variable. That's not a number, so it's a little more difficult, but following my exponent rule, I multiply exponents, so what's 3 times x? 3x. Just 3x, so I have m, oops, need my pen, m to the 3x power. Okay, all right, so let's look at some of the mixture problems where we have to do 2 different rules. So remember, as we talked about a second ago, I'm looking at PEMDAS, I do exponents first, okay? So anytime I see this base to a power to another power, I always have to do that first. You have to be able to recognize when power to power is happening versus when just multiplication is happening, okay? So this first piece is base to a power to a power. So I have 4 n's written out 3 times. So if I have 4 of them written out 3 times, 4 times 3 is 12. So this first piece here is n to the 12th. And then I also want to multiply that by the n piece, which is just n to the 5th. And I don't care if you use a multiplication dot or parentheses. It doesn't really matter how you denote multiplication. But now you can see that this problem has no more power to a power. It's literally just multiplication. I have n to the 12th times n to the 5th. So that means I have 12 n's back here, 5 more here. What do I do with those exponents this time? Add them, right? I have 12 of them and 5 of them, so that makes my final answer of n to the 17th. Okay? All right, and then let's look at E, which is along the same lines. So first piece, I have 4 A's written out twice, so 4 times 2 is 8. So I have A to the 8th power. That's my first piece. My second piece is another power to a power. I have 2 A's written out 5 times, so 2 times 5 is 10. So my second piece is A to the 10th. Now I just have multiplication, right? Each has its own base, each with its own power. So I don't have power to power anymore. I just simply have 8 A's here, 10 A's there. That makes a total of 18. So A to the 18th power. Okay, can I get a comfort level on where you're at with power to power so far? Good. Okay. Now let's mix in some coefficients, okay? So say I have this expression that is 5y, all of that to the 3rd power, okay? Remember, it does not matter what's inside the parentheses. It just matters that that is being multiplied out however many times the power is. So 5y to the 3rd power would simply just be 5y times 5y times 5y. Well, you guys should all know, what is y times y times y? Ooh.
Y to the third power.
Y to the third, right? Y times Y times Y is Y to the third power. Is 5 times 5 times 5 15? No, right? So, moral of the story there, you cannot apply the same rule to coefficients that you apply to exponents, right? What was my saying about coefficients? Do what you see. You got it. Okay, for coefficients, you do what you see. What do you see here?
5 times 5 times 5.
You see 5 times 5 times 5, which is the same as 5 to the third power, right? 5 to the third power does not mean 5 times 3. 5 to the third power means 5 times 5 times 5. So 5 times 5 is 25, times 5 would be 125. So my answer there is 125y to the third. Okay? So that goes back to the same old rule I was preaching the other day. You have to know the difference between bases and coefficients. Okay? It matters. So my little statement under here says, if there are parentheses around the expression, the exponent is applied to the entire expression. Stylus is messing up. This means raise the coefficients. Oh my goodness. It's majorly dead. Let's see if I have another one in here. Oh, I do. Okay, let me see if this one works a little bit better. No, it doesn't. Oh no. I'm going to have to write with my finger. This is going to be terrible. Let's get rid of this mess. Okay, so I need to multiply or raise the coefficients and the bases to the exponent. Okay, so let's try one together here. Okay, so I always go through and do my power to power first. So let's look at A. So each of my sets of parentheses, those are two big parts. I'm going to do both of those parts first because they both have an extra power on the outside. So they're both power to power. So I have C to the second to the third. So that means I have two C's written out 3 times. So 2 times 3 is 6. So my first piece that I'll do in blue is C to the 6th power. Okay, that's that first piece. Now let's look at my second piece, which I will do in red. Okay, is 3 a base or a coefficient? Is 3 a base or a coefficient, guys? Coefficient, right? Because it doesn't have an exponent on it. So I do what I see. 3 to the 4th power. What is 3 to the 4th power? Don't say 12. Yeah, 3 times 3 times 3 times 3. Your calculator is going to be your best friend here, okay? But if you don't have a calculator, 3 times 3 is 9, times 3 is 27, times 3 is 81, okay? So my coefficient for the second piece is 81. And then apply your exponent rule. So I have 5 C's written out 4 times. So 5 times 4 is 20. So I have C to the 20th. Okay? Be perseverant. Work the problem all the way through to the end. I'm not done yet. What kind of problem do I have now? Do you see any extra powers on the outside? Hello? No, I don't either. Okay, so it's not power to power. What kind of problem is this now? What do parentheses mean? Come on, guys. Multiplication. Okay, so I'm just multiplying nothing times 81 is a big old fat 81. And then I have 6 C's back here and 20 C's over here. How many does that make? 26. C to the 26th. So I have 81 C to the 26th. Okay, you guys work B and C together with your partners, okay? Work B and C together with your partners. Go ahead. Okay, so take it piece by piece. I'm going to do the first piece in red, I guess. So I have 2 x's written out 2 times. So 2 times 2 is x to the 4th. That's my easy one. The harder one, the second piece here, I have negative 3 to the 4th power. Negative 3 is a coefficient, so I have to do what I see. If I have a negative to a 4th power, what's my answer going to be? Positive. Okay, then I need 3 to the 4th, so that's 3 times 3 is 9, times 3 is 27, times 3 is 81. Then I have a single x written out 4 times, so that's 4 x's, x to the 4th. And I have 2 y's written out 4 times, so 2 times 4 is 8, that's y to the 8th. Then I need to go back and multiply. Nothing times 81, again, is 81. I have 4 x's up front and 4 x's in the second term. That makes 8 x's, x to the 8th. And then I also have y to the 8th that doesn't get combined with anything. Okay, questions on B?
I don't understand how you get 81.
3 to the 4th. That's 3 times 3 times 3 times 3.
Oh, I forgot about that.
Yep, gotta be careful with coefficients. Okay, and then C, again, coefficients, do what you see. So I have negative 6 to the 3rd power. If I have a negative to an odd power, a power of 3, what's my answer gonna be? Negative. And 6 to the 3rd power, that's 6 times 6 is 36. Times 6 again is, I think, 216. Is that right? So I have 216. I have a single m to the 3rd power, so that's m to the 3rd. I have 6 n's to the 3rd power, so 6 times 3 is 18. So I have n to the 18th. So that's my first term. Second term, I have 5 written to the 2nd power, so 5 to the 2nd, that's 5 times 5 is 25. And I have 3 m's written out twice, so 3 times 2 is 6. I have m to the 6th. Be perseverant, finish the problem. Can somebody help me out with negative 216 times 25? Negative 5,400? Yeah. Okay, I have 3 m's up front and 6 m's in the back. That makes 9, so m to the 9th. And then I also have the n to the 18th. Okay. All right, do we have any questions? Let's just get a comfort level before we move on to division. Okay. That's a little rough. That's okay, though. We'll get there. Practice makes perfect, okay? We got a lot of 2s, and that's okay. All right, let's look at division. Okay, so division is essentially the same thing that we just did. Regardless of what is inside the parentheses, the exponent outside applies to everything, okay? So x over y to the 3rd power is simply just x over y times x over y times x over y. So what is x times x times x on top? X to the 3rd. What is y times y times y on bottom? Y to the 3rd. So moral of the story is this exponent out here applies to everything on top and everything on bottom, even if there are multiple pieces on top and bottom. Okay? So it says, if there are parentheses around the expression, the exponent is applied to the entire expression, just like it was above. This time we're going to put the second sentence in terms of our fraction here. So this means raise the, what's the top part of the fraction called? Numerator, good. And the bottom is called? Denominator. Last year I think I got nominator and the demonator. I remember that one. Somebody said the demonator. It kind of scared me a little bit. All right. But anyways, it applies to everything top and bottom. Okay, so if we look at A, is 4 a coefficient or a base? Ooh. Doesn't have an exponent on it, so it's a coefficient. So I do what I see. 4 to the 3rd power. So that's 4 times 4 times 4, which is 64. And then on bottom, I have 2 x's, and I write that out 3 times. So 2 x's written out 3 times would be 6 x's, so x to the 6th. At this point, if you can simplify your fraction, you need to. Okay, just like we learned last class, but obviously this one cannot be simplified, so it's done. All right, you guys try B and C together with your partners, and then we will have a little bit of homework time at the end, okay? So try B and C together with your partners, and then I'll come back with answers in a minute, okay?